Blender. I love Physics 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 Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing how to use converging and diverging lenses to correct long-sightedness. Long-sightedness is known also by hyperopia and short-sightedness, which is known as myopia. Okay, before we start, as usual, you can find KWL chart if you join Physics Blender Telegram channel. You can find all documents, questions, classwork, homework, quiz assessment, and mark schemes. Kindly write down here what you know about long-sightedness, short-sightedness, and how they can be treated. What about treatment? What you want to know about long-sightedness, short-sightedness, and at the end what you learned. Okay, let's start by question number one. Question number one, before I start this lesson for extended candidates only. Okay, question one, a man is short-sighted. The main difference between short-sightedness and long-sightedness, short-sighted person, he will see the far away object blurred, not clear. Why? Because the refracted rays inside the eye, they will not intersect at the retina. They will intersect in front of retina. Okay, so in this case, the answer is C. So a distant object will, this person will not be able to see this distance object clearly, far away object clearly, because the light rays will not intersect at a certain point at the retina. So this will be the case. Okay, so that's why we are using diverging lenses to correct this short sightedness. Is it clear? So the answer of this one is C, so they can see the distant object or far away object. They are seeing this objects blurred. Okay, the second question, the other case, which is hyperopia. Long-sighted, a girl is long-sighted. Let's discuss each statement. Okay, she sees close objects less clearly than a person with a normal vision. This one is the correct one. She sees the close objects, the objects which are near. Okay, they can see these objects, but they cannot see these objects clearly. Why? Because the light rays in this case will not focus correctly on the retina. They will be formed, the image will be formed behind the retina. So the answer is A. She cannot see close objects clearly. That's why in this case the correction or the treatment in long-sightedness we are using convex lenses. Converging lenses are used. So the image for treatment So the light rays will focus correctly on the retina. What happened in long-sightedness? The image is formed behind the retina. Is it clear? Question 3. What is the name and shape of the lens used to correct short-sightedness? Again, guys, short-sightedness, this person is not able to see distant object, far away object. They cannot see them clearly, and the image is formed in front of retina. So we are using diverging lenses to push the rays so they can correctly arrive together and focused at the retina. So you have to choose diverging lens, and you know the shape of diverging lens, it's thinner at the center than the edge. Question 4. Which statement here about human vision is correct? In a normal eye, the image on the retina is magnified and upright. No, it's real, it's inverted, and it's like the case of camera, so it is diminished, real, and inverted. So this one is not correct. In a long-sighted eye, distant objects from images in front of is formed in front of the retina. In long-sighted, the image is formed behind retina. So in long-sighted, it will be behind, not in front of. So also this one is not correct. Short-sighted eyes produce only virtual images? No, in all cases, the images are real. Short sight is corrected by using a diverging lens, right? We said it right now, earlier in the last question. Okay. Question number 5. In a short-sighted eye, light from distant objects is not focused on the retina, right? But is it in front of or behind? In case of short-sightedness, the image is formed in front of retina. Where is the light? I said it, in front of the retina, so we have to exclude A and B. And how it can be corrected? The treatment to correct this problem, you have to use diverging lens. So the answer is D. Is it clear? Okay. We have, these questions are repeated. Okay, we have, this question is very important. We have a normal eye shown in figure 5.2, but we have long-sighted eye viewing an object at the same distance in figure 5.3. Can you complete the light rays traveling through the eye on figure 5.3? Yes, we can do this. Long-sighted, you know that the image will be formed behind the retina. So the rays will be formed behind the retina, so you have to complete the light rays to meet behind the retina. Okay, so this is how you can show long-sighted eye. Again, guys, long-sightedness, the image or the rays will intersect behind or will meet behind the retina. How you can treat this or correct this? By, in long-sightedness, by using convex lens, converging lens. Is it clear? Okay. The next question, we are discussing short-sighted eye, which is called myopia, short-sightedness. And we have here rays of light from a distant star. So they are parallel. They will refract, but refraction of light as they enter the eye will be ignored. You have to continue the light rays in this case until they strike the retina. We will draw the one here at the center. We'll continue undeviated, and we have here this one. It will refract and here will refract, and they will intersect in front of the retina. In case of short sightedness, they intersect in front of the retina. Okay, that's why. So the image is blurred. Why? Because we don't have focused rays at the retina. And how this could be corrected? By using diverging lens. So by using diverging lens, they will push the light rays further apart so they can arrive all together at the retina in proper focus. Okay, so we already drawn the first part. Explain how your diagram shows that the image of the star seen by the observer is blurred. Why the observer is seeing blurred image? Because rays do not intersect or do not meet at a point on the retina. Okay, is it clear? This question is very important. You have to draw and you have to differentiate between short-sightedness and long-sightedness. So here it can be treated or corrected by using diverging lenses.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor.